We are now discussing something about the gravitation. So as I said, the gravitation is nothing but the influence between the bodies in the universe, and the influence is attractive force in fact. So it is one of the basic forces in nature. That is what the first point we have noted from the gravitational property. The second one is the force is always attractive. There is no repulsion in fact in case of the gravitation. It is only attractive force. So it is always attractive. Now we are to look at what is the amount of force, with what magnitude of force these bodies are getting attracted in the universe. In order to look at that, Newton has given one popular law called as Newton's universal gravitational law. So what does it mean? So what it tells about? In order to look at that, we look at what does it mean by Newton's universal gravitational law. Here the statement says the force of attraction between two bodies in the universe, any two bodies, is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. So in order to define, in the universe, consider any two bodies. If their masses are, let us suppose, m1 and m2, these two are separated by certain distance. That means the gravitational force can be between any two heavenly bodies like Earth and Moon and the Sun and other planets. Anything you can take, and when a body is placed on the surface of the earth, because of the gravitational force only, the body is remaining on the earth's surface. It is pulled towards the earth's surface. So you can take any two bodies. So whatever the bodies you want to calculate the force, you have to take the two bodies. Their masses are supposed to be m1 and m2. Now the separation between them is r. Here the statement says the force of attraction between two bodies in the universe is directly proportional to the product. So one thing is that it is directly proportional to the product of their masses. Directly proportional to the product of their masses. So F is directly proportional to the product is m1 and m2. Mass m1, mass m2. These are the two bodies. First one mass is m1, second one mass is m2. Therefore, it is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. So, between these two bodies, let us say the distance is r. Then, inversely proportional. Inversely proportional means if r is increasing, in fact, r square is increasing, f is decreasing. So, inversely proportional. F is directly proportional to 1 by r square, which means it is inversely proportional to r square. So whenever you are to write inversely proportional, you have to keep that in the denominator. Whenever you are to write directly proportional, you have to keep it in the numerator. So F is directly proportional to m1 and m2 and inversely proportional to r square, distance square. Therefore, the mathematical form of this particular definition can be written as F is directly proportional to m1 m2 by r square. So whenever you are writing a proportional, to remove that proportional, we have to write one constant. So whenever the same thing to be expressed in the form of an equation, you have to take one constant of proportionality that I am writing as g over here. Therefore, F is equal to g m1 m2 by r square. So this is going to be the force acting between the two bodies in the universe. So mathematical form of this force or the amount of force that acts between the bodies can be given as F is equal to g m1 m2 by r square. And now here this proportionality constant is called as universal gravitational constant. So G is called as universal gravitational constant. And how you can measure this G value? G value here you can measure. So when you want G, then F into R square by M1 M2. G equal to F into R square by M1 M2. Which means F is Newton, R square is meter square because distance is measured in meters according to SI system. And kilogram square, mass into mass, kg into kg is kg square. Therefore, units of gravitational constant comes out to be Newton meter square per kg square. And its value is going to be 6.67 into 10 power minus 11 Newton meter square per kg square. These are the units anyhow, and the magnitude, the value of this G is 6.67 into 10 power minus 11, and this value is going to be constant everywhere in the universe, not only on the surface of the earth, on the moon, on the sun, on the Mars, on the Venus, whatever the planet you take, the value going to be the same. G, capital G value does not change with respect to a planet or a body. G value is constant. It's a universal value. So, G everywhere, whenever you are to take in the calculation, you can take this as the value for capital G. Whereas small g value is going to vary from planet to planet depending upon its nature. But here capital G value is not going to change. And in our day-to-day activities or day-to-day examples, you can see the gravity comes into play whenever a body is thrown upwards. Then it will be going to certain height and then again falling onto the ground, which means it's a natural force that pulls the objects towards the earth. So it can never go away from the earth as long as gravitational force is present. That is present to certain extent, of course. So whenever the objects are allowed to fall, they are coming towards the earth. That is because of the gravitational pull. So gravity is the reason for their coming back towards the earth. Similarly, you can see the sun. Sun is a star. Around the sun, planets are revolving, including the earth, Venus, Mars, Saturn, all these things. So these planets are moving in certain orbits because of the force acting between them. Therefore, the gravity holds the stars together. That is one more example you can take. Similarly, a moon is orbiting around the earth, which means moon is orbiting around the earth because of the gravitational pull towards the earth. There exists a force acting between them. Because of that, moon is orbiting. So that is also because of the gravity. And also, to certain extent from the surface of the earth, there exists an atmosphere. So these atmospheric particles are oriented around the earth to certain heights because these atmospheric particles are pulled towards the ground because of the gravity. That means gravity also plays an important role in keeping the atmospheric particles surrounding to the surface. So these are the examples of gravity in our day-to-day life. So this is how the gravity plays an important role. So what is gravity and how the gravitational force can be calculated, everything can be discussed in this particular way.